Okay, being 2 past, let's officially start. Welcome all to this interim meeting of the co-working group. This is Marco, chairing solo for today. And of course, it's an official IETF meeting, so the note very well applies. Please be nice to each other. You have to disclose any personal knowledge of IPR that apply or not participate in a technical discussion as an alternative. We have one agenda item for today proposed by Carlos and Anna. Thank you. On the possible ways to enforce co-op message aggregation that came up with co-op over bundle protocol, but may have a more general applicability and was already touched on during the Bangkok IETF meeting. So, Carlos, the floor is yours. You can request slide control.
So I requested slide share. Is it correct?
Pues so. There you are. Oh, looks like it's still loading for me at least. Oh, there you are.
Okay, perfect. Okay, thank you. So, well, first of all, thanks for accepting our request for a slot in this interim. So, my name is Carlos Gomez, and along with my co-author, Ana Calveras, we requested a slot to discuss about the topic, as it has been introduced by Marco, on message aggregation. So this is a topic that has been around for a while, in the working group, also in the past. But the point is that now in the co-op over bundle protocol, we are trying to define a mechanism for message aggregation. And there's a couple of things we'd like to discuss about it, as it will be shown over the next few slides. So first of all, as a little bit of an overview, in the co-op over BP draft, we currently define an aggregate message as a concatenation of single messages that carry the payload length option. So this payload length option is a new option defined also in the same draft, and single messages are basically co-op messages as defined in the base co-op specification. And as it has also been introduced by Marco, we already received a few comments on this topic in Bangkok. And if I recollect it correctly, it seemed like participants received positively the idea of message aggregation, but perhaps there were some concerns about the technical approach to actually enable it. And the aim of this presentation is actually to discuss what would be the pros and cons for considering the technical approach to enable message aggregation, as in fact in Bangkok there was not like much time to go further into details, and we also hope that perhaps this may help a bit when we prepare the next version of the draft. So just a reminder, the new payload length option would indicate the size of the payload of a co-op message. The option value would be an integer number of bytes. And again, it allows message aggregation since each one of the individual messages carried as part of an aggregate message would carry the payload length option. And well, on the slide, there's some details about the features associated to the definition of the option, already presented, by the way, in previous meetings. And well, it's a pity that Karsten is not present today, but he's still somewhat present. At least we try to channel here his feedback from Bangkok. And basically, he expressed that there may be a concern with the current approach. And he expressed it as the fact that in order to determine which is the message size for one of the individual messages carried as part of an aggregate message, then it's necessary to parse all the options to determine the size of an individual message, at least with the current approach. And it would be nice to avoid such a need. So Karsten himself already suggested a couple of possible alternatives. The first one being incorporating information on the length of the co-op message as part of the co-op message header, similar to how this is being done in RFC 8323 for co-op over TCP. And perhaps another approach could be use something like the payload length option, but perhaps with a low option number, such as, for instance, option number 0. So trying to elaborate a bit more on these two alternatives, on the slide we are looking now at alternative 1, which is again providing message length information as part of the co-op message header. And we had a question, which is whether this idea was intended only for co-op over BP, because perhaps it could work for co-op over BP, but then what about supporting message aggregation over other transports, say UDP? For instance, there's the related draft Untitled Co-op in space, which is assuming co-op over UDP, so there's not the bundle protocol there. And perhaps there might be other use cases where message aggregation could also be interesting. So perhaps one thing to discuss would be whether we would like to have some sort of mechanism that works over different transports, or perhaps we might have like specific approaches over specific transports. Well, that's one thing that perhaps could be discussed. And in any case, we went through the exercise of trying to define a possible format for co-op over BP, well, for the header, for the co-op message for co-op over BP, in this case, incorporating length information. And well, it's the one that you can see in the lower part of the slide. First of all, we need to take into account that the bundle protocol is similar to UDP in the sense that it's a message-oriented protocol. So most of the fields that would be present for co-op over UDP would still be present here. However, we removed the version field, the first 2 bits of the message, to add some pointers about the presence or not of length information. So basically, bit 0 in row 0, the L bit would indicate the presence or not of length fields later in the header. And that's also because perhaps in some cases we want to include this information because we want to do message aggregation, but perhaps in some others we don't need to do message aggregation, and in that case maybe we might not need to include the length information. So let's assume that we do want to include length information. Okay, in that case, the L bit indicates so, and then the length field in the first row would be present. This would be an 8-bit field, and if necessary, this length field could be extended by using additional fields. You can see that on the right in the first row, there's the extended length field. So there are some related details about this here. And basically, the base length field is an 8-bit field. So we can represent here sizes between 0 and 252 bytes. And this is, by the way, considering from the first bit of the options, including also the payload. And the approach followed here is not new. It's actually the same approach as in co-op over TCP. The only difference being that for co-op over TCP, the length field has a size of 4 bits. So the related numbers here are a little bit adapted as a consequence, but the approach is the same as in co-op over TCP. So this would be alternative 1, defining some new header format, at least for co-op over BP. And the alternative 2 would be, okay, keep the same current approach. Each individual message in an aggregate message carry a payload length option, but then perhaps try to use something like option number 0, perhaps another low enough number. So this second alternative would work without the need to modify the co-op header over UDP, for instance. So it might work as is, let's say, and not only over BP. And perhaps then the issue could be, okay, option number 0, for instance, is currently reserved, and we were wondering, okay, would this payload length option be like special enough, important enough to really deserve the assignment of such a critical number, option number like 0, or perhaps another low enough number? So yeah, these are like the two alternatives that were suggested by Karsten. Perhaps there could be other alternatives. And this is more or less what we wanted to discuss. We would be happy to receive any feedback to see whether there's like any sort of preference or any particular advantage that you guys might identify considering these alternatives or perhaps others. So yeah, this is basically all our slides. So any feedback on this?
Thanks a lot, Carlos. I think Christian already had a few questions in the queue.
Hey, yeah, thanks for working on this. I do have a few. Starts with remark and goes into questions. So anything that is done with a header will generally not work across transports. It looks like it would work well with COAP over UDP and COAP over Quick, COAP over the UDP and bundle protocol. But other transports just have different header structures. So I'd hope that we find an approach that does not go into the header, so that it can work on different transports. And from there, I think it's more in the direction of questions. So, what are your expectations on how this would interact with proxies? Would you is this something that should rather like be sent to a proxy, and maybe that has another like proxy behind it and proxy behind it, and then there is a host that actually knows how to unbundle them? Or is this really something you expect every proxy to need to support? And it depends a bit on whether you expect the requests to all go to the same origin server, or if you really expect them to be sent to proxy, and then the proxy can dispatch them to like one here, one here, one here.
Yeah, that's a good point. And actually, I guess we didn't think about it so far. Yeah, because perhaps let's say an endpoint, an actual endpoint, say an origin server who might be, say, a sensor that may perform aggregation. That might be one case, but then perhaps a proxy could be also aggregating messages from different actual origin servers. So I understand this would be like different scenarios. And yeah, I'm not sure about what would be the implication about how we support like for instance, if let's say we keep the current payload length option, let's say with a low option number, would this create any issue, for instance, for the different scenarios that you mentioned, considering presence of proxies?
So the precise option number will probably not influence this. I mean, or the precise option number will have an influence, but that's more about what number gets picked, because the numbers are semantic, and whether or not a proxy needs to support this depends on that influences a bit in the option number.
Yeah. So do you mean that there could be issues like existing proxies not supporting this, like sort of middle boxes from this point of view?
Yeah. The good thing is that will not be an issue in the sense that it creates that it breaks anything, or that it creates unforeseen consequences. The consequence of a proxy, if this whole scheme is supposed to work with proxies that know what is going on, then that will be encoded in the option. And if a request hits a proxy that doesn't support it, the proxy will know to refuse it. So we don't get the unforeseen consequences. We just get the foreseen consequence of if there's a proxy that doesn't support it. Yeah.
Okay.
But maybe let's go. I don't have a good answer here yet. Maybe let's go through a few other questions that are also kind of help me get a good picture.
Okay.
And one is, oops, sorry, Marco. Do you expect a lot of commonalities between those requests? So, for example, if we take a mindset of this could go to proxy, do you expect that it's a common case that they all have, say, a URI host option that should not be repeated, or is this really something that, like, it's a message and a message and a message, and whatever they do, the kind of any duplication between them is more accidental?
Yeah, that's another good question, and probably we don't have like a sort of already thought answer, but yeah, perhaps again it might depend on the scenario. Maybe it makes sense trying to aggregate messages where that are not so related among each other. So yeah, I think that, for instance, say a proxy might be receiving CoAP messages from, say, some origin server, well, responses, let's say. Perhaps they are not so much related, but at some point we might want to aggregate them. Then I'm not sure if the final endpoint for that aggregate message should be like one client, or maybe like one sort of origin client, or maybe let's say that it's possible to have like a couple of proxies between the actual endpoints, and maybe there's aggregation only in the middle, let's say. So that's some scenario that perhaps might make sense in some case. But definitely, yeah, that's a good point. Yeah.
And your point leads right to the next question. That is, it's probably in the draft. I'm sorry, I haven't read this ahead of time. What is the plan for responses? Would the responses all, like, if I send out a bundle of requests, would making gestures doesn't work without video. Sorry. Do you expect the responses to come back in a single bundle, or sorry, in a single aggregation, or would they be more like observation notifications, where like they come in as the response is ready?
So do you mean if perhaps we can aggregate messages which are already themselves aggregate messages from some previous node, perhaps? So not sure if that was the...
That's not what I'm asking. The question is,
okay,
if assume no proxies for the moment. A client sends a request out that has 5 sub requests.
Okay.
Would there be a single response message with all those sub responses, or would all the responses come in individually?
Well, I guess it may depend on the application, let's say. It might make sense to, I don't know, for cases where we need to quickly get some response, not to try to aggregate that message carrying the response with other messages. Maybe in other cases where we may be a bit more delay tolerant, it might be possible to maybe attempt to do message aggregation. So that's my initial reaction to your question.
Yeah. I like that this is like that it could be anything, but this makes the response matching quite difficult because right, co-op matches the responses based on the token. So if the response can come in individually or can come in as an aggregate, like if it's only one of those, it could be like if, for example, all the responses must come back as an aggregate, then you could see that there's like 5 requests and 5 responses. They all have one token because the token is part of the header and shared across all the parts. And then like the first response for the first request, etc. If they're split up, it gets more complicated, but it also gets more powerful. Because then the responses kind of need to indicate like, what am I the response to?
Yeah.
And that's something there's probably no mechanism for here yet. One more question. Sorry, please tell me if you disagree, but I think it makes sense to open like more of the questions and then see what we can reasonably tackle and go from there.
Okay.
So the like next question from there is, what is the interaction between the requests? So if there are 5 requests being sent, is there any intention of them being like an atomic operation, or at least have something like you send sorry you send the first request, then you get the response, and even if the response is not yet set, only then you process the second request? Because they're like, are they supposed to be processed, at least in theory, at the same time or in sequence? And is there any consequence of any request failing?
Very good question as well. So again, my thoughts on this would be that again, the application should decide whether we want to keep requests sort of atomic. Then we might need to make sure that okay, if we do message aggregation, like not to break anything, like allow the requests producing the responses and not break anything. So I guess we haven't thought that yet, but we may want to think about it and see, okay, what could be like issues if in some cases some things might need to keep like sort of atomic or not.
So like when you go through this with examples, I think that the easiest approach will be to say that they are all independent requests. The server can like reorder them in any way, and if you want to have interdependencies between requests, like the one has to be processed after the other, just wait for the response and send them individually. That will probably be the easiest, especially considering that if you want to have this processable by proxies, like the proxy will also need to make a choice, like, will I now send them off individually, or can I just send them and like they might be reordered over UDP and it still works? So I don't know what the best will be here.
Okay.
And after all those questions, there's a suggestion that I have, but I'm not sure. Like it's just a bit spitballing here. It might make sense to not try to do this as in a protocol extension, but more on the application layer. So I'll try to sketch this out now here in the notes if you can follow this. So one thing that OSCore does is that, in a sense, it does something like a co-op request packed into a co-op request. And maybe it makes sense to take a similar approach here. And the way I'm writing it is a bit more explicit. Or maybe even do you see what I'm typing?
Yes, yes. Thanks, by the way.
So what I'm trying to show here is that this could be like on the co-op level, a regular single post request that creates some kind of request state on the server that might be very short-lived because it could come back. And then maps those out at the application layer again with responses. And that could be, there are different ways of how this could be done precisely, but the point is that if this would work across any proxy, and either the post goes to the proxy, in which case it would be that proxy that does the splitting up, or it could be to the origin server, in which case the origin server is the one that that processes that. And the response, and this would allow us to mix and match those responses, because we could, on one hand, have immediate responses, for example, like have the payload immediately in here. But we could also indicate that this request is still pending and it will be fetchable, or it will be, I don't know yet how that would work out, sent to a particular return address. Maybe here we would have to phrase this like this. So if there's any extra information, that might just be a bit or two. It has to be a byte if it's CBOR encoded, but if there's extra information that says you can send this as a later response, then the client would be in control of saying that it wants to have all the requests bundled, or it wants to have some of the requests bundled. And quite possibly it could even say something like sub3 and that depends. Sorry, my syntax is getting worse and worse here, but
Okay, no worries.
this is just after successful. So it could. This could be an application format where we have a bit more leeway in terms of negotiating between the client and the server what is supposed to be done with the individual requests.
Okay. So in this case, there would be a co-op request carrying several co-op messages as payload, right?
Yeah.
Okay.
And my guess here for setting up the syntax would be that this is something like that the co-op message in there would be using the on the wire co-op encoding again, but just the code and then options and payload. This is very similar to what you already have in the extension option. So this is a bit more on the complex side. If we can do it with the alternatives, also fine with me. I just wanted to point out that this might be an option. And as you go through the questions that came up, I think that will guide whether or not you need something more complex anyway, or whether you can pick whether the choices that work with a very simple single payload option, whether those work out.
Okay.
But that will to a large extent depend on the open questions there. For example, the proxy stuff.
Okay. Yes.
So there's one in terms of matching the requests and responses. There is a document that you might want to have a look at. What's it called? Core responses. I'll put the link in the notes right away. So that covers different things, but I think looking at it might help understand how things could go if there are supposed to be multiple response messages to a single request message. So for example, if you want to have that, I'm sending a request and two things are urgent and they get sent back as the best responses are available, and then there are a few bulk requests and they get bundled together, for lack of a less loaded term, then they will produce what in this document is called non-traditional responses.
Okay.
And at least that this kind of responses is around needs to be negotiated with the proxy.
Okay.
What I'm a tad curious about is like the bundle protocol is, I mean, it's kind of in the name. So, is this neat? I understand why this is relevant for co-op in space when going over UDP, but does not the bundle protocol have internal mechanisms to bundle multiple messages in a single data object?
Well, the bundle protocol provides some sort of encapsulation, let's say. Well, now I was thinking there's something called bundle in bundle, but let's say by default with normal bundle protocol, I understand that it just takes what some application entity provides as payload and will transport that, and the destination bundle node will receive that and will take the payload from the bundle and will pass that to the application agent. And so I think that it doesn't have like it has no logic or not more than that, because actually it's like this would already be sort of application layer behavior, and the bundle protocol would be like below that, and it's sort of out of scope as I understand it, for the bundle protocol.
So that the bundle protocol bundles multiple applications on a link, but it still sends their messages as individual messages.
Yeah.
So the reason I'm asking is if this is just a concern for UDP, I'm a bit wondering whether like there has been talk in the deep space meetings that I've been very tangentially listening to about using things such as quick as a transport on the high bandwidth, high processing power links.
Yeah.
And if that is if that wherever that is an option, it might be a good idea because you would get all the benefits of that. So if this is just if bundle could solve this internally, and UDP and this just remains an exercise for UDP, because for example in COAP over TCP you don't really need this because you could just nail the requests together and they go in through a single MTU anyway. Then this might be this whole thing might be a non-issue. But yeah, if bundle protocol can't do that, then
yeah, as I understand it, we can double check things, but I believe that the bundle protocol, say from the sender point of view, would take some payload that has been generated by the application layer, and that payload should already be aggregated if that's what's intended. So I believe that the bundle protocol doesn't have sort of a way to be the aggregator, let's say. Yeah. Yeah, in fact, actually, the idea of message aggregation was suggested once in a DTN working group meeting. And it was suggested for us like to be addressed in the core over, in the CoAP over BP specification. So I understand it also indicates that possibly the bundle protocol itself cannot do it.
So DTN is the working group that specifies bundle, right?
Yes. So they don't like to be like officially seen like that, but it's more or less.
Okay.
Yeah. Yeah.
Thanks, Carlos. Christian, did we actually reach the end of your early points?
Yes, I think so.
Okay. Well, thank you very much. Great discussion also for the application level proposal. I just had a few comments more on the initial way of thinking and the slides. So yeah, I also think it's just better to have a single solution that can work ideally on any transport. Also thinking of the transport that can be translated by intermediaries. Now taking separately the option approach and the header approach. For the option, I don't think it's a problem to unreserve reserve option number per se if you have a good reason, like this seems to be. Probably the exact value 0 is a problem here, considering the properties you like this option to have, and 0 is not aligned with those, unless we really admit a mega exception as a kludge. You really want an odd number, and before we were even discussing it's better if the option is even unsafe to forward. So that restricts the scope even more. And yeah, 0 can be not good as a value, which brings up the original Carsten concern. Yeah, an option is good, but you just need to parse all the way until you reach it, and probably this is just unavoidable.
Okay.
Yeah, so you mark this as critical already, which makes total sense. And yeah, I guess it has to be also unsafe to forward. Yeah, that rules out 0 already because it's critical, right?
Okay.
So I haven't done the math to check what the first non-assigned value fits the intended properties, but yeah, you may end up moving quite far away
Okay.
in the pool of numbers. Yeah, whatever that numbers, I think intermediaries may end up changing the value of that option, considering even what they do themselves by manipulating or adding, removing options themselves as intermediaries. I understand from the semantics of the option that you take into account the amount of bytes starting from where the option begins onward, right?
Well, as it's currently defined, it's the
I think it's in
payload
the next
size.
slide. Maybe it's the next slide.
Okay, yeah. So, well, or previous.
No.
So, yeah, well, so in the current attempt, let's say in our draft, we would say, okay, the option value is the size of the payload. Not sure if there might be like better ways or to make it easier for devices to process this, but this is the current one.
Okay.
I think that's good, and because like that's a length that every client needs to, every node needs to work with anyway, and also the node can't process the payload before it has passed all the critical options. So, from my point of view, no harm in having a high option.
Yeah, it's only about reaching it, but that's probably unavoidable. I'm thinking of OSCOR also. So if I'm not missed it, the draft is not mentioning how the option is supposed to be processed by OSCOR. I suppose it's class U or even more. I think if you want to use OSCOR at all, this option has to be added after encryption, because OSCOR in itself creates a payload altogether or extends the already present one. And well, that's what you want to indicate with your option at the end of the day.
Okay.
Right? Imagine, 5 requests aggregated in a single bundle. So in each of those, you're supposed to find this option, but telling you the size of the OSCOR protected payload. So you add the option after the OSCOR protection.
Yeah.
Right.
I mean, it really depends, right? I mean, if you have a single origin server, there would actually be a lot of efficiency be gained from doing this whole thing in class E and having a concatenated request processed through having a set of requests processed through OSCOR and then having that length always as a class E option.
Oh. When you take each request from the aggregated set, how do you know where the first request ends, for example?
Because it has a class E payload length. So for you, it might be easier to visualize this if you think of the OSCOR only being added on the proxy to proxy leg.
Yeah, I probably need to see an example. But of course, the OSCOR-related processing is something to factor in designing all this.
Yeah. Okay.
So all in all, to be flexible also from different transport point of view, the option seems to be the safest way, and well, it's supposed to be the extensibility point in the protocol. So no surprise with that. And we can try to go for the smallest option number possible, but still you have that constraint of being aligned with the properties you want.
Yeah.
For the header, I understand it is least convenient, also thinking of different transports or transport translation. Just to be sure we don't miss any possible opportunity, I admit it's a hack. There is a possible other spot that you can play with. I'm thinking of TKL. The full meaning of TKL for a few years now is defined in RFC 8974 for the extended token size. And one value of TKL, meaning 15, is reserved and not to be used. In principle, you may define that value to be used. And if you have that value, you may have TKL with value 15 followed by the real TKL, again, the semantic of 8974, and then your new fields there, with the catch that you need to be aligned with the byte again. So what you called length there should be 12 bits, not 8.
Okay.
That would open the nice possibility of each request having its own token. But I do agree that it's like it's not really a favorite option.
No, it's a kludge. I just wanted to be sure we had it on the table, even for ruling it out. But
okay.
But in principle, you have the two around. Yeah, and before I was probably mixing things up. The indication of the size counting from the options included was something you were doing here in these length fields.
Yeah, that's
that's right.
Yeah.
I was thinking of this slide.
Okay.
That's right. Okay.
Yeah.
But with the option, with the payload length option, you actually indicate the size of the payload.
Yes.
Okay. Yeah, they were mostly my comments.
Okay, so, well, I don't know if there may be other comments, but, well, it's absolutely great feedback, and thanks a lot, because it's very valuable feedback, very detailed as well.
I suggest to follow up on the thread you started on the list, Carles, on this particular topic.
Yes.
That was a few weeks ago or so.
Yeah.
Yeah, and we take it from there. I'm sure Karsten will also comment on the result of this discussion on the list.
Yeah. Yeah, so, yeah, I understand I can, well, yeah, I may possibly add the link to the minutes and provide some short summary of some of the discussion, and yeah, and perhaps, well, at least everyone in the mailing list will be able to see that.
Please do.
Perfect.
Okay. You have any more input or question, Christian?
No, sorry, that's all I have.
I'm not complaining.
Me neither.
Okay, then. Great discussion. That brings us to the end of the official agenda. Do you have anything more you wanted to check or discuss for core today? If not, we can take back 40 minutes of our life, roughly, and talk to you in 2 weeks and on the list.
Thank you all.
Thank you for your answer.
Thank you.
Thanks
again. Thanks a lot.
Bye-bye. Bye-bye.
Thank you. Bye-bye.